Hey everyone, this is Matt Myers, the Valuation Professor. This video is a quick guide on using the Hewlett-Packard HP10BII Plus, that's a mouthful, financial calculator to solve for the various time value of money problems typically presented in real estate, banking, or finance courses. This video is not teaching about the concept of time value of money. It's just a quick guide on how to use the HP10B calculator to solve the various functions. So let us begin. (1987) as a substitute for the previously more well-known HP12C, which actually also was previously known as the HP12B financial calculator. The HP12C is still produced, and it's generally the real estate and finance industry's go-to calculator, but it's much more expensive, usually about twice as much as the 10B, and also uses a different type of input called RPN, or reverse Polish notation. So sometimes people find that a little more confusing. So the 10B is out there. It's much more common. It's great for introductory real estate courses, and it works for most things. And I have both a 12B and a 10B, and I use whichever one's more convenient at the time, but they both work great. The 10B Plus was last updated in 2015 with a new processor, therefore it's much faster than it used to be on solving some of the more complex things such as the internal rate of return. The 10B Plus is pretty commonly found throughout the world. Literally taught around the world, from South Pacific, Australia, the US, the UK, and now here in Dubai. And I've found it available in every one of those markets. In the UK, they're generally about 30 quid or under. Here in Dubai, they're usually about 120 to 150 dirhams. In the US, you can usually find them for less than $40. So basically, the HP10B is a financial calculator, but it has a bunch of storage registers. So I want to highlight how this works. In this case, you look at the top of the calculator, there's 5 buttons that are keys that we will regularly use for time value of money. So you'll see them there. You got the first one, which is N, which is the number of periods. I/YR is the interest rate. PV, present value. PMT is payment. And FV is future value. So most of the stuff that we do in finance, in real estate finance, we'll be using those keystrokes. Sometimes we'll have situations where the payment's at the beginning of the period or the end of the period. And so again, taking time value of money courses, I've explained that to you. So this allows you to make a quick change to do that. And also sometimes you need to input numbers as a negative number. So you can also do that by change signs. And the shift button, and sometimes I call it the orange button, you'll see that the orange button in this case, where the begin/end button, is the lower part of the MAR button. And so to get access to those orange characters, you have to hit the orange shift button first. And you need to clear it often, but what happens is the time value of money registries actually store the information. So those numbers are stored there unless you clear them out. And so it's good to make sure you regularly clear out the calculator. And to do that, to clear all, you hit the orange shift and then the clear button. In different parts of the world, you hear 1,000 markers. Some people use a full stop, marker we call it a period, or other ones use a comma. For example, 1,000. Well, most countries that use a comma go 1,000. Some European countries would use 1.000. So you can change that on the calculator for every year market that you want to deal with, and you just do that. And also sometimes the number of decimal places that you want to work with. Often I work with 2, but sometimes I don't want any, sometimes I need more. So I can easily make a change there using the display button. So a little more detail on the other tools. You can adjust the brightness. Pretty easy. You just hold the on button, either plus or minus. Very straightforward. in, as I mentioned earlier, the decimal places. So basically, to assist with that, you select the orange shift, select the display button, which is the same as the equal button, and then you hit the number of places that you want to actually do. So now once you've done shift equals, hit 2, and then you'll see the register at the top actually shifted from no decimal places to 2 decimal places. Again, the separator, just use the orange shift, and then hit the full stop button on the bottom, which is also the comma slash, and that will change your display. Again, if you look at the register on the screen, it changed as we went through this. Another one's really important is setting the number of payments per year. Often when we do time value of money, we're looking at one payment per year when we talk cash flows, particularly in real estate. And so normally you want to set it to a single payment per year. Often, but when you do mortgages or car payments, you set it at 12 payments per year. But if it's set at 1 and you need to do the other, you'll get the wrong answers every time. So if you want to set the number of payments per year, you just type in your number. In this case, you want 12, hit the orange shift. And then if you look on the bottom of the payment key, you will see a P/R, and now it will set it to 12 payments per year. But I usually leave mine default to 1 just because most of my work is done that way. And earlier I talked about clearing out all the registers. Again, just shift, clear all, and now do it. But most importantly, look at the register at the top. You'll see it says 1 P_YR. So when you do the clear all, it's telling you what it's set at for the number of payments per year. So had I already put in 12 payments per year, it would say 12. But when I did this one, I was at that time set for 1 payment per year. So it's good to know what that is. That way you get the correct answer. So this video will be looking at the different 6 functions of a pound, or sometimes 6 of a dollar. It can be the euros. It can be pesos. It could be the wongs. It can be all sorts of different things. So it's any currency. The calculator doesn't know what currency. Since I'm teaching for a Scottish institution, we use pounds. Originally, you can tell by my funny accent, originally American. I've also taught in Australia and Fiji. In those countries, we'd say 6 functions of a dollar. Same process, it doesn't matter. So let's go ahead and start. Again, I'm trying to make this a quick video. And these are just samples to show you the relationship and how to do those keystrokes. In this one, we're trying to find the future value of 1 pound. So in this case, the example is we got 1,000 pounds deposited in an account. It earns 6% interest per year. The question is, how much will we have at the end of 8 years? You can see the cash flow on the bottom where the cash flows are coming and going. But more importantly, you just want to know how to use the keystrokes. You'll see the first 2, I say optional best steps. You should do clear all, make sure it's set to 1 compounding payment per year. If these have already been done, you don't have to do it again. But it's, in a perfect world, if you do these first, you'll minimize your mistakes. But effectively, you need to figure out what's the number of years. And you'll see I have these laid out. I usually, in practice, I look at the top. First one I need is years, then the interest, then present value, payment, future value. So I just do them in that order. So again, in this case, we know it's 8 years, which is 8 payments. We got 6% interest per year. We have 1,000 present value. But what you'll notice here is the plus minus sign. So you have to kind of think of this when you're in your cash book or your checkbook. When you make a payment, you actually take it as a negative. So from your perspective, you've given away 1,000. The question is, how much will you get back? And this sounds like it's a little subtle, but you'll find sometimes when you do your calculations, you may get a no solution pop up. It's because you haven't figured out the relationship between positive and negative, which way the cash flows are going. So again, we 1,000 negative present value. There's no payments. Then you just solve for future value. And you'll see you come up with 1,593 pounds and 85 pence. Straightforward, that's it. The calculator, again, 8 in, 6i. You do 1000, do your shift, and then take it to the present value, 0 payments, then solve for future value. Technically, if you hit the clear all at the beginning, all of those registers would have a 0. So in this case, where it says 0 payments, you actually didn't have to redo that if you did the clear all. But again, it's a safety thing because sometimes you may have done a calculation, there's a number stored there. So I just do it as practice, but you don't technically have to. Now we're going to look at present value. And present value is taking money from the future, bringing it back, what's it worth today. Get same cash flow timeline there for you. Then look at the steps involved. Again, go straight across the keyboards. 6N, 10I. Again, there's no payments. Then you solve for future value. In this case, you're going to see you come up with a negative 6209 and 21 pence. And that's because the present value is how much you would have to give out. So again, technically, mathematically, it says it's negative 6209. But someone says, how much would you have to give? You would still say 620921. You wouldn't say negative. So you have to think about what you're saying versus the mathematical sides. Strokes again, 6N, 10I, 0 payments, and solve. The next one we're looking at is the future value of £1 per period. In other words, you give payment per period. So here's the timeline again. In this case, we're using payments of 2,000. And it's important to make sure you see where it says end of the year, because annuities are always assumed at the end of the year for payments or deposits, whatever you want to say, but it's always assumed at the end of the year unless it's called an annuity in advance. So again, we got our, again, those 30 years, 7.5%, 0 present value. The keystrokes, 30N, 7.5i, 0 PV, then 2,000, change signs, payments, solving for future value. And this is those annuities in advance. So now we're going to do the same thing, saying, hey, what if the payments that you're putting in there were at the beginning of the month versus the end of the month? And so therefore, you can do the same problem, do the calculations, but all you're going to do is use the begin end function to solve for future value. So if you've already solved the previous exercise, all you have to do is now do the shift orange, get the new number. So, but also it's important, look at the register or display on the top. You'll see the BEG. So that's telling you that it's set for your payments at the beginning of the period. So if you do an exam or something for those students, your numbers don't match where it should be. Often people have left it on beginning or didn't consider that. So, and if you did a previous exercise where the payment was at the beginning and you didn't change it back to end of period, that BEG will stay there. So always kind of be aware of that. The present value of £1 per period, which are what we use most commonly in valuations because we're saying how much income we're going to get and to come up with the current values. Same thing, number of years, interest, what the payment's going to be. In this case, because you're solving for present value and there is no future value, you're going to have that. And 12i, excuse me, last one was 10N. 12i, 500 payments, 0 future value, solve for present value. So basically, to get those payments, you would have to spend $28,000 today to get payments of $500 for 10 years at 12% interest. Sinking fund factor is basically trying to figure out what the payment would be. And so you're asking, well, how much should the payment be in this case to accumulate to have £10,000 at the end of 10 years, assuming 7% interest? And so same thing, number of years, what's the interest rate? In this case, you start out with 0, so that's why 0 present value. And you want to know how much at the end is 10,000. So the payments in this case would be $723.78. 10N, 7I. Payments. Again, very straightforward. Partial payment factor. And this is also pretty much the same as you'd use for a loan of such. It's like how much you have to pay back to pay off an amount. Or in the future, or the sinking fund factor, you were trying to figure out the payments to get a future value, to get a certain known number in the future. Partial payment factor, sometimes called an annual constant, sometimes called a mortgage constant if it's done monthly, looks at, here's a present value, how much to pay off that loan to be fully amortizing. In other words, getting to a balance of 0. So what's the payment per period for a loan at £200,000 at the end of 5 years with 6% rate? Again, it says 5 years, 6I. The present value is $200,000. In this case, you've actually received it. Usually if you're the one who's giving or receiving the loan, but if you're the banker, you technically gave out the loan. So you got the payments, as you solve for payment, your $200,000 present value, got your stuff. In 5N, 6I, 200,000 present value, 0 future value to get your payments. Now, if you want to make those a monthly payments, because typically most loans for cars and real estate is done on a monthly basis. The previous one assumed annual payments. Well, how many people have annual payments for a car payment or house payment? So there's several ways to actually convert this to monthly. These terms, monthly, years, dollars, currency, the calculator doesn't know it. They just know numbers. And so you gotta make sure the numbers go into the calculator properly. So monthly, you can either set the calculator to 12 payments per year, which again, you do your clear all, and just go 12, orange shift the PYR button. Now it's set to 12 payments per year. So if you do that method, you still put in the annual interest rate and the number of years. So it's not just the number of payments, the number of years, and solve. The second method is instead of changing your payments per year to 12, you leave it at 1 payment per year. Then you actually just manually make your own changes. So again, the calculator, when it does N, it's looking for the number of periods, not years or months, number of periods that this covers. Well, if you have 5 years and the monthly payments, that's 60 periods. So basically it's going to be 5 times 12, and then that gives you 60, and that's N. At the same time, you got to remember your interest rate's being reported at an annual rate. So you have to take that 6% and divide it by the number of months, and then solve for that. The other two remain the same. If you want to convert to quarterly, well, it'd be 5 times 4 is 12. 6 divided by 4 is 1.5I. When you want to do it twice a year, again, 5 times 2, 6 divided by 2. And so to me, it's easier to do it that way, and I don't have to worry about going back to the next problem and setting it back to 1 payment per year. Because if I did the previous method, 12 payments per year, it stays there. So to me, I prefer this one. But again, there's multiple ways to get the same way. And with that, I'm going to make this a wrap. Thank you for watching. And stay tuned. I will have additional learning videos coming throughout the semester. on time value money or other ways to do calculations within HP 10B and Microsoft Excel. Cheers.